Hi, welcome to the presentation of our work on ICCV 2023, Few-Shot Dataset Distillation via Translative Pre-training. The researchers are from the National University of Singapore. Dataset distillation aims to compress a given original dataset T into a much smaller synthetic dataset S, so that the networks with random initialization trained by S can perform well on T. Existing approaches always require iteratively optimizing S through multiple neural networks as shown in the figure. In each iteration, a new network is initialized randomly and trained by the current S. The trained network is evaluated by T, and then the error is backpropagated to S. This step is known as neural feature regression, or NFR in recent works. The whole process is slow, since the optimization is conducted iteratively in multiple neural networks. Thus, in this paper, we are curious about one question. Can we achieve satisfactory DD performance with only one neural network? To study this problem, we first introduce the definition of distillation space according to this target. Informally, we define the specific neural network satisfying the following property as a distillation space. The performance of synthetic datasets only optimized in this network can approximate those optimized by multiple neural networks. With this definition, one can come up with a naive solution to find a distillation space according to its definition, as shown in this figure. After the distillation space is initialized, in each iteration, we optimize the synthetic dataset S in this space and conduct a step of NFR in another random network. The loss is backpropagated to the space to update it. This naive solution is inefficient, since the optimization is nested in 4 levels. We thus consider a more efficient translative fashion. Specifically, as shown in this figure, S is first optimized in a random but fixed neural network, and then translated to the result optimized by a distillation space. We propose a pre-training algorithm to pre-train the translator on a large-scale dataset like ImageNet. First, we randomly initialize the translator and a random but fixed neural network. Then, in each iteration, a subset T is sampled from the large dataset. S is optimized according to this T in the random but fixed network, and is transferred to the final S prime by the translator. S prime is conducted with a step of NFR in another random network. The loss is backpropagated to the translator. Compared with the naive solution, the procedure of updating S is detached from the computation graph, which reduces the memory complexity by an order. For a target dataset, the pre-trained translator only requires a limited number of steps to update it to a translator specifically for the target dataset. Experiments suggest that our method based on few-shot adaptation runs multiple times faster than existing state-of-the-art algorithms with comparable performance. Ablation studies also validate the effectiveness of the pre-training stage compared with a translator adapted from scratch and from an autoencoder. Interestingly, it can achieve cross-storage budget generalization as shown in the third plot. For example, a translator adapted in the settings of 1 image per class and 50 images per class can conduct inference for the setting of 10 images per class. In summary, in this paper, we introduce the setting of few-shot dataset distillation, introduce the notation of distillation space, and propose a novel translative pre-training method. It achieves multiple times of acceleration compared with existing approaches. Thanks for listening.